Okay, so this video is about transformation, specifically reflection. This is when you flip an object across a line, which we call the line of reflection. So we'll show a reflection across the x-axis and across the y-axis, but actually you can reflect an object across any line that you define as the line of reflection. So this is a type of rigid transformation. It means it doesn't change the size. Of the shape. And because of that, all the rigid transformations, they prove and maintain the congruence of the shape. So the original shape or the pre-image is same size, same side lengths, or congruent to the original shape. So the original shape is congruent to the new shape. So let's take a look at an example here. So here's our initial shape, VWXY, this polygon, and we're going to reflect it across the x-axis. You can see we're flipping it over the x-axis. That means that the x-axis is our line of reflection, or the line we're going to reflect it across. So imagine this is like a mirror, and it's looking at its reflection. So let's record the vertices of the original shape, or the pre-image. So the coordinates of those are going to be V, W, X, Y. So V is 3, -5, and W is -1, -2, and X is -2, -2, and Y is -1, -4. So this shape is going to flip over or reflect across. So notice a couple things. So one way to think about this reflection, or to check that you've reflected the object correctly, is notice if this is my line of reflection, right? This is the line it's reflecting across here, the x-axis. The distance from the axis to the x vertices here is 2 units. Hopefully you can see that. Well, look at the distance to the x prime there, also 2 units. If we look at this y, it's 4 units away, right? 1, 2, 3, 4, 4 units from the line of reflection. And that y prime is also 1, 2, 3, 4 units. So each of these vertices of the original or the pre-image, we'll label this as pre-image. And this is the image or the new shape. So we're flipping it across here. Each of these points is the same distance. V is 5 units away, and V prime is 5 units on the other side. So everything just flips to the other side. So let's record the coordinates of the new or image, and let's see if we can see a pattern for this reflection. So V prime, there's V prime, so that's 3, 5. And then W prime is here, that's at -1, 2. And then X prime, there's X prime, -2, 2. And Y prime, there it is, -1, 4. So if we were going to write a description of, said verbal, but also a written description, it would be that we are reflecting across, and then you name that line of reflection. So if it was just any line, you would say the equation. In this case, it's the x-axis. So that's what we're doing, right? We're reflecting this, we're flipping it across the x-axis. But the algebraic representation, or the expression, let's zoom out just a bit, the algebraic expression or representation of that move is what it does to the coordinates. So let's see. So from V to V prime, Look at the x coordinates. They stayed the same. Look at w to w prime. X coordinates stayed the same, -1, -1. X to x prime, -2, -2. So the x coordinates stay the same. So the algebraic representation for the x coordinate, or what happens to it, is just x, meaning it stays the same. So my old x coordinate is 3. I would plug that in here to see what would happen when I do the reflection, and it would just stay the same, right? I plug a 3 in here, it's a 3. And now let's look at the y coordinate. So the y coordinate of v was -5, and v prime is 5. W was -2, the y coordinate was -2, became a +2. Same here, 2 became, oops, that's a mistake, x prime. Oh, this guy should have been -2, sorry. Yeah, x is -2, -2, there we go. Good, so we caught our mistake. So it was -2, became +2, this was -4, became +4. So we can see that the sign of the y coordinate changed. So we would put -y here, meaning my old y coordinate before the reflection is -5. I plug -5 in here, I get -5, becomes +5. If I plug my old y coordinate in of -2, I get -2 is +2. So when we reflect across the x-axis, we can see it changes our y coordinate, which makes sense. If I flip over this, my x coordinate is not changing, right? This was at -2, it's still at -2. W is at -1, W prime still at -1 for its x value, but its y value is flipping from the negative side here of the y-axis to the positive side. So when I flip over the x-axis, I'm changing my y value sign, but keeping my x coordinate the same. So let's look at one more example of that. Actually, first let's remind ourselves about that this is a rigid transformation, so it maintains congruence. So, for example, the side lengths, right, are going to stay the same. So an example of that, if we look, side xw here, so xw is 1 unit long. Let me make that a little farther apart there. And so then its corresponding line segment here, x prime, w prime, without measuring it, right, we should know that it would also be 1 unit because this shape is congruent, right? These shapes are exactly the same size, so their line segments, corresponding line segments, should not change in length. Same with the measurements of the angles. Whatever this angle is, angle x, has some measurement, right? The measure of angle x is equal to, we can see these angles are the same angle. So it's the same as the measure of angle x prime. They're not going to change. So the same side lengths and same angle measures, which is the definition of being congruent, right? Same side lengths, same angles. So we can see the size of the object stayed the same. This is the same size as this, so these are the same. The orientation changed, right? Our original shape is kind of pointing down right. This is pointing upright. So the orientation or positioning of the shape, sorry, like the direction it's pointing, changed. And the orientation of the vertices, how we read the vertices. V, W, X, Y, right? These are going counterclockwise, right? This was counterclockwise in this case. And now V, W, X, Y, we're reading them clockwise. So it changed. So they changed. So when you flip or reflect the shape, you are changing the orientation or the direction it's pointing. You are changing the direction that the vertices are read, or the orientation of the vertices. But the size stays the same. Angles stay the same. Side lengths stay the same. Which means those shapes are congruent, which is true for all the rigid transformations. It's true for translation and rotation and reflection. Excuse me. So notice, let's do one more reflection here. Notice this time we're reflecting across the y-axis. So the y-axis is our line of reflection. So where before we flipped it across the x-axis, this time flipping across the y-axis. So our original QRST, our original points, Q is -1, 3. Hopefully I'll get my signs right here. R is -2, 5. S, -4, 4. And T is -4, 2. Now before, if you remember, when we went across the x-axis, right, we changed the y value, or the sign of the y value, but we kept the x value the same, right, because we were flipping over. So our x value stayed the same, but our y value flipped. So this, hopefully you can see, would be the opposite, right? So here, if we look at Q prime, right? So Q is flipping over to Q prime. It was -1, 3, and this point is 1, 3. So in this case, our y value stayed the same, but our x values flipped, which makes sense because the x value is flipping over, but the y value, or the up direction, right, of the position of this point, it's still up 3, right? It's up 3 either way. So in this case, we're going to flip the x coordinates, but our y coordinates should stay the same. So x of -4 becomes 4, and the y coordinate of 4 stays, and this -4 becomes 4, right, or t prime, 4, 2. So the verbal or written description of this move, right, is just that it's a reflection. So we would say reflect, and we could name the polygon, reflect, QRST. We'll do that this time. Reflect QRST across, this time, the y-axis. And that's what we did, right? Here's QRST, that's this guy, and we reflect it across the y-axis. Here's the y-axis. So this is our line of reflection. And the algebraic explanation of that, or description, or expression, how the coordinates changed. So we had the old x value was -1 became +1, -2 became +2, -4 became 4, and -4 became 4. So the x value we're going to put here -x, meaning that I'm going to plug in -1 for x, but this is -x, so I'm going to get -1, which is +1. If I plug my old x value in, I would plug in -2, so I would have -2. So let's do an example of Q here. So for Q prime, right, you would plug in the -1 from Q, but you would have -x there, right? And then our y stayed the same. So we plug in a 3, we keep a 3. So evaluate this, right? This says -1 would become 1. 3 stays 3. So Q prime is 1, 3, which is what we got, right? We plugged in the x value from Q to make Q prime, so that -1 became +1. So when we reflect across the y-axis, we're going to change the sign of all the x values and just keep our y value. So again, remember this was reflection, which is one of the rigid transformations. So these shapes are congruent. You can see they look like they're the same size. It just flips them over that line of reflection. Also remember that it's very common to reflect across x and y axis, but that doesn't mean you could only reflect across the x or y axis. You could reflect across any line. You just name it. At the equation of the line, you reflect across that line. And in that case, we would not see the same pattern. This is just for reflecting across the x-axis, and this is just for reflecting across the y-axis.